Okay, so now we are in the coding segment of the stream, and I'm going to be talking about a whole bunch of stuff that I've been working on for the past couple of days. So, what should I start with? So, the most recent thing. Actually, let's go a little far back. I had worked on. I'd worked on a packed version of my body pose message protocol. Well, I mean, the body pose message protocol was supposed to be the packed version. I worked on a packed version of the regular message protocol as well, just so I can, for the most part, avoid having to use JSON. And I tested it out as well. I'm really leaning more towards using the packed version, mostly so that I can just not use JSON at all. But like, I might still use JSON for like one-off things, or if I'm doing like my I don't know, if I'm doing like my if I'm trying to trigger something from my remote control app, which by the way I still have to make that app. It's going to be like my own little stream deck, but it's going to be running on a different system. And through that, I'm going to be able to send messages into my VTubing app to trigger various things. But yeah, I spent time working on that, and I'm going to be going back to that again. I wanted to work on doing audio stuff, because it seems like doing audio stuff, or at least, okay, more specifically, recording the audio in Unity, it seemed like it was going to be a little hectic. I don't know how well I'm going to be able to do performance. How do I say this? Performance optimized stuff when it comes to recording audio in Unity. Like, there is a way of recording audio, but like things get kind of complicated. It also doesn't help that Unity's audio is like it's a serialized asset. So when the audio is recorded, you're able to create an audio clip out of it, but that audio clip is a serialized asset. And so that has like its own little extra data and stuff like that. So I don't know how that's going to complicate sending things over the network. Basically, what I wanted to do is I wanted to be able to use the audio that I'm recording from my mic, like as I'm speaking. I wanted to be able to record little chunks of it and send it over to a Python script, where it will then be fed into a speech-to-text model, and that speech-to-text model is going to spit out text, because, you know, speech-to-text, and then I'm going to send that text over to I'm going to send that text back over to the VTubing app, and that's going to be our closed captioning. So I can then have a closed captioning system set up. But then after seeing first of all, how limiting Unity's recording thing was, and also what I would have to do, like how I would have to go about it, because it has to be a seamless stream kind of thing. And it just seemed like doing it from within Unity was not going to work out that well, unless I managed to use somebody else's library or something. And it seemed like it was going to be more headache than it was worth. So I came up with another idea. Because I'm going to be running the Python script on a different system, I mean, even if I'm running it on the same system, it's fine. But like, because it's going to be like the data is going to be going to a Python script, right? It's going to be going from the VTubing app to the Python script. So why not, instead of doing it in the VTubing app, why not just record the audio in Python itself? That way I can record the audio and directly feed it into the ML model, into the speech to text model, and then get the results and then send those results to the VTubing app. That way the VTubing app doesn't have to send any data over, and well, I'm going to be able to record directly in Python as opposed to recording in the app, sending it to Python, and then processing and then sending the data back. So yeah, I started using this library called PyAudio, which, according to the author, it provides Python bindings for a library called PortAudio. So essentially we have like I believe this is considered a cross-platform library. Let me just look that up. So I have the thing open here. Where is it? So this is the documentation. Yeah, PyAudio provides Python bindings for PortAudio, the cross-platform audio I/O library. With PyAudio, you can easily use Python to play and record audio on a variety of platforms. And yeah, I've been using this. I love how simple it is to record audio. But before going deeper into this, like I tried out the examples, and I even got the results. It was stupid simple, like crazy simple. I was super happy about how simple it was. Give me a second. I just realized I haven't activated the environment. So let me just do that. So what is it? env, I think scripts. I have to remember the difference between activating the environment on Windows and activating it on Linux. What was it? Activate. Okay, done. And now we can just run this. Give it a second while it does its thing. Also, give me a second while I hydrate. All right, great. So, what was I saying? Okay, I forgot what I was saying. But anyways, I started learning about PyAudio. It's fairly simple. It's not too complicated to learn. And they also have like the documentation and examples that'll get you started like real quick. But before going deeper into it, I needed to go back and learn the basics of digital audio, because at one point in time I did some music production as a hobby. I made a couple of songs, and so I made a lot of songs, but like it was a hobby, and I was learning at the time as well. So due to that, I did learn a little bit about digital audio, more specifically how audio is represented digitally. That is not an easy word to say. How audio is represented digitally, as opposed to analog. So I needed to learn digital versus analog audio, but more specifically the digital part. What was I saying? Oh yeah. So I wanted to understand some of the core concepts, some of the basics, in fact. Stuff like what is sample rate, what is bit depth, what is There were a couple more things. But yeah, I needed to understand like how the audio is represented and what these various terms mean. And I learned that. So I learned that sample rate is basically the number of samples per second that the number of samples that are used per second, that are used to represent 1 second of audio in that file, or in that whatever track, whatever the track might be. So if a track is saying it's using a sample rate, or made with a sample rate of 44,100, that means each second of audio contains 44,100 samples or frames. And this is per channel. So if it's a one channel audio, if it's a mono track, it's going to be 44,100 samples per second. But if it's a stereo track, if it's a what is it two channel audio, then it's going to be double, so 88,200 samples per second. There's a reason I needed to understand this, because I was trying to understand like how you would manipulate audio in terms of like samples, because like you're dealing with samples when you're looking at it like in the digital format. So I needed to understand properly exactly how what was going on with the data that I was looking at. Another thing is the bit depth. Bit depth is basically how many bits are used to represent one sample. And the sample usually contains the amplitude of the signal. So when you look at the wave, the sound wave, how high it is, if it's high, the amplitude is high. If it's low, the amplitude is low. And that information is I guess you can say encoded in the sample. So the samples are basically used to represent the sound wave, but it has to be represented in a way that the computer can understand. So you have this method, which is breaking it up into samples, and each sample represents the amplitude at that specific slice, at that specific point in time, and how that amplitude is represented depends on the bit depth. So if it's 16 bits, that means you would represent each sample with using 2 bytes, or each sample's amplitude would be represented as 2 bytes. There's a lot of other stuff that I learned as well. I can't remember right now. There was a bunch of other stuff as well that I was curious about, and I'm glad that I looked into it before going deeper into PyAudio. Another thing I was super happy about is the fact that Audacity lets you generate tones. So you can generate a sine wave, you can generate a square wave or a sawtooth wave. And well, I don't know if they would be called waves. Curves, I guess. Whatever, I don't care. You can generate them at different frequencies, and then you can export that wave file and then read it in Python and like study the data. That's what I did. I was debating whether, because I'd done it on a different system, even the generation and stuff. I was debating whether I wanted to bring that data over into this system, because it's just wave files, but like I would then be able to play that audio as well, but I won't be able to show the curve, which is why I wanted to open up Audacity and like generate. Do I have? Did I ever install Audacity completely? Because I think I downloaded Audacity. I downloaded the installer. I don't know if I ever installed it. At one point in time, I did have Audacity, but like I don't. I think I removed it after some time. Yeah, I don't. I don't think I have it. Okay. All right. Okay. So, today what we're going to be doing is I'm going to read some of this documentation. Before the stream, I wanted to just get some of my basics down, doing like basic file input output and stuff like that. And yeah, I did that. Something that I've been trying to understand. I haven't completely wrapped my head around it. But okay, so we need a couple of things here, right? We have rate, which is, I guess, the sample rate, right? Yeah, that's what the rate is. Hold up. There was the thing here. Okay, so there's chunk, there's rate, there's the format, number of channels, and number of seconds to record. Okay, so the chunk part is something that I haven't fully understood yet. Chunk is 1024. Then there's format. Where is it from? PyAudio. PyAudio dot the fuck PA and 32 in 16. What else was there? Num seconds. So let's say I want to record 5 seconds of audio. What else do I need? I think that's it, right? Oh, channels. We are recording mono, so we'll just do one channel. Okay, so once that is done, then we can directly do this. This was also I believe one of the first times I've used the width keyword in Python. I haven't done it a whole lot in the past, despite having used Python for such a long time. I think maybe I might have used it when I was doing like file stuff, file IO, but I just forgot about it. So like width is, it's basically, it's a way of, it's similar to the using statement in C#, where anything that needs, anything that's a resource that needs to be freed later on, like you have to release the resource or close whatever the thing is that's open, that'll automatically be done for you, so you don't have to explicitly close it. So here I'm trying to, what was I trying to do? Open, wave.open, let's say output.wave, and this has to be in this mode, as I don't know, WF, wave file, write file. And then in here, we do our entire thing. Man, that stress is hitting my throat, my vocal cords early. I haven't streamed for like, I don't know, 1 week, maybe 8 days, 9 days. And like, I'm feeling it. Give me a second. Let me hydrate. Oh, is the music still going? Let's just confirm. Let me go and click around on the page. Okay, great. Awesome. Right. So, the idea is that we open the file, right? And then we initialize PyAudio here. Okay. Oh, then we have to set the channels, set the sample width, and set the frame rate. Okay, so wf dot set channels. Oh, this is another thing that I explored, which was the wave, the wave module. I hadn't messed around much with the wave module. Fortunately, I didn't even have to install anything for it because it comes with Python like out of the box. Okay, channels. Then what else was there? Format. What? It says p dot get sample size format. Oh, okay, so set sample width. If I'm setting sample width, why do I need to get the sample size? What does this do? It returns the size in bytes for the specified format. Oh, okay, so I don't have to do the calculation myself. Oh, all right. I mean, I could just as well. I could just as well do. Wait, no, hold up. Wait a second. So the sample size. Hold on. Returns the size in bytes for the specified sample. Oh, for the specified sample format, which in this case it says 16, so it's going to be 2 bytes anyway. So yeah, I could set it myself. It's good to know though that this is the case. So I could probably pass in. Would this work? Would the enum be converted anyways? Yeah, that's an int, right? So I think it would be converted anyway. So I could just pass in format. That being said, I just need to do 2, so that's 2 bytes. And then what is the thing? Set frame rate. So this is another thing that this is something that confused me, and so I had to look it up, and then I figured out that, oh, in this context, frame and sample are the same thing. So when they say frame rate, they mean sample rate. Which in this case is rate. So 44,100. Great. So with that, we then have to open up a stream. So p.open. We set the format, we set the channels, we set the rate, and set input to true. Okay. Wait. Are they... Okay, so there's rate, there's channels, there's format. So we can do it that way. So the rate would be rate, channels, format. and then input equals true. So that's going to make it record. So after that is done, from what I remember, they ran a for loop, right? You start the recording and then you run a for loop. And this is kind of where I got a little bit confused about how they were going about doing this. So like the logic was for so-and-so in, oh my God, what is going on? Okay. For range in 0, 0 to rate floor divided by chunk multiplied by num seconds. That was their logic. And then we write the frames chunk. I believe it's just chunk. No, it's not just chunk. It's stream read chunk. So we read from the stream. And then we write whatever's been read to the wave file. Finally, after we are done, we need to close the stream, or I think it's terminate. No, it's close. So we close the stream, and I believe we have to also close the file. No. Do we need to? I think we need to. We also need to terminate this. I'm not sure if we need to terminate or close. Be sure to call this method for every instance of this object. Okay, all right. What about close? Closes the stream. Okay. I think I should use terminate. Maybe terminate calls close implicitly. Right, so after we are done with that, it should create a file called output. I'm not sure which device it's going to be using because I didn't test that. Okay, here's what we can do. Okay, we add a statement here. Print recording. And then print done. And now we run the thing. Check. No. Check, check, testing, testing. Check, check, testing, testing. Hello. Okay. So it created the file. But VS Code doesn't play the file properly at least on Linux. It didn't. I don't know if it's going to play it properly here. You know what? Let's test it out. Because like it has this thing open, right? Maybe I was missing some setting on VS Code. It might play properly here. It might also be loud. No. Check, check.
Oh, there it is.
Check, check, testing, testing. But how loud is that? No. Check, check, testing, testing. Check, check, testing, testing. All right, cool. So as you can see, that's how simple it is to record audio. I can probably write another cell to play the audio as well. You know what? Let's do that. It'll be good practice. So let's import wave, import PyAudio. Then we have to set the, I don't want to. Okay. So then we open. Though in this case, how is it reading. Just a second. Let's minimize this. Right, so if we go for just playing, it's writing to the stream. How's it playing? Is it because output is true? Yeah, I haven't read this part a whole lot. You know what? Let's do a bit of reading. So they gave an example. They also something else that I liked was that there is a callback version for at least for play and wire. I haven't tested out wire yet, so I'm not sure exactly what it does, but I think it maybe does something like playing and well, recording and playing it, or recording it and streaming it. Okay, what is this doing? Okay. Well, it's doing a similar thing. Full duplex wire between input and output. So it can go back and forth. Okay, input is true and output is also true. So does it read and then simultaneously also play? So that's kind of like monitoring it, right? It's like live audio, which I kind of need that. Well, I mean, I might need that. I might need that. Damn, dude. I'm yawning like crazy. Give me a second. Okay. So we'll look at wire later. Wait, what is channel maps? Mac OS only, play. Oh, is this a Mac only feature? What is channel maps? Hold on. I've never heard of that. Channel map. Channel mapping. Although several pieces of software exist for describing surface, pockets, and channels in no, this is a different thing. Okay, well, I mean, it says that this is for Mac OS only. So back to what I was saying. Something that I liked was that while there is a blocking version of the method, there's also a non-blocking version. So you can set it up with a callback. So once it's done, it'll trigger the callback, and that way you're not blocking the thread. Versus this, which will block while you're doing your recording. And in my case, I don't want it to block. So I'm gonna be, because okay, I need to understand the logic here, because we are reading in chunks. So I need to understand exactly how this is reading. But like we read 1024 bytes worth of data. And then we write that to the wave file. And this same thing, this happens for this long. Well, for this long, which is how long does that? Let's create a new cell. Print. What was it? Chunk divided by, right? So let's do 1024 divided by, or let's do a floor division. Was it chunk or was it rate? No, it was rate divided by. So the rate is 44,100 divided by 1024. That's 43. And then that would be multiplied by 5. Which would be 215. Now what I need to be able to visualize is how exactly this is happening. So because like, okay, the thing blocks the thread, right? Let's take that as a starting point. It blocks the thread. It started its reading operation. It reads 1024 bytes. Well, I mean, okay, so we are trying to read for as long as... Oh, okay, I think I'm getting it. Hold up. So if we consider that multiplication is done before division, right? So then... Oh, wait a second. Multiplication is done before division in that thing. So I'm supposed to be doing it like this. That makes sense. Yeah, multiplication is done before division. Right. So 1024 into 5 would be what? I mean, 1024 into 4 would be 1496, right? This would be 5120. Okay. So here's what I'm trying to get. Here's what I'm trying to understand. It reads 1024 bytes in each for loop, in each iteration. But it blocks until it reads those 1024 bytes. Like, this is what I'm thinking, right? Because it's a blocking operation. It's not the for loop that's blocking. It's this stream.read operation that's blocking. Wait, isn't it? Isn't it the stream.read that's blocking? Do not call when using non-blocking mode. Yeah, okay, so this is a blocking operation. Read samples from the stream. So I need to go deeper into understanding the stream. Like, what exactly is going on there? And I'm not entirely sure I'm going to get much information from the PyAudio documentation. I think I have to go into the PortAudio documentation. Let's Google that. Give me a second. Actually, I need to do some stuff, so give me more than a second. Right. What was I gonna do? I was gonna look. Okay, so PortAudio stream. Opening a stream using defaults. Oh, there's an ad playing. You know what? Good time to hydrate. Okay, welcome back. So I found this thing. I believe this is going to be helpful. Yes, I think this is going to be helpful. I'm just Googling some other stuff. Well, I'm Googling on another system is what I mean. Streaming and processing in real time. So-and-so. So I think I got the simple answer for what I was looking for. A stream represents an active flow of data, of audio data between your application and one or more audio devices. A stream operates at a specific sample rate with specific sample formats and buffer sizes. The stream operates at a specific sample rate. Oh, that's what I was doing when I created the stream, isn't it? Yeah, there you go. It operates at a specific sample rate with a specific format. Oh, and buffer sizes. Okay, all right. Okay. All right. So PortAudio. Wait a second. Maybe I should just read this whole thing. I can open this up here, so it's visible on stream as well. I can do that. Okay, just a second. So what? PortAudio API overview. No, PortAudio stream. Let's just do that. Opening a stream. Okay. All right, great. We are here. So we're going to read. We're going to do a bit of reading. Okay, so should we read the whole thing? Like, I feel like I would get a good understanding if I did that. Though, okay, it's worth noting this is a library. This library is made for doing audio stuff in C. But like, I'm just trying to get a better understanding because PyAudio is basically Python bindings for this library. So, wait, did I say this library is meant to be used with C? I don't remember if I said C, but I mean C++. I believe it's meant to be C++, or is it C? I think it's C++, or is it C? Third-party language bindings make it possible to... Oh, I think it's C. I think it's specifically... I think it might be specifically C. I think so. Oh, yeah, there you go. Open source C language library for real-time audio input and output. Okay, all right, great. Okay, so like I was saying, uh, my point is that what I'm reading right now is not meant for Python. This documentation is for this library specifically, which is written in C, but PyAudio is basically Python bindings for this library. So that's why I'm reading the documentation of this library. Okay, so you know what? I don't think it's too much to read. Let's read. Let's read. Because there's a whole lot of, like, they're explaining a whole bunch of things here. Let's do some reading. Let me zoom in so I don't have to, like... Can I see the whole diagram still? Yeah, that's the whole diagram. Okay. I need to get this. Okay. So, PortAudio provides a uniform... Oh, just a second. You know what? We are reading, right? Why don't I make this full screen? So we could do this. And oh shit, that's gonna be like that's gonna be what, light mode. Just let me just put that out there. It's gonna be full on light mode. What was I? Yeah. I need to move this. Okay. Great. Now we can transition and read. Okay, so PortAudio provides a uniform API across all supported platforms. You can think of the PortAudio library as a wrapper that converts calls to the PortAudio API into calls to platform-specific native audio APIs. Yeah, so then that basically becomes an abstraction layer. Which, in a way, that's what it is, right? It's an abstraction layer. Well, okay, I don't want to say it's only an abstraction layer because it might be doing a lot more stuff than just abstracting. Because the whole idea with an abstraction layer is, okay, I make one call, I make one method call, but then that method call is gonna call the specific method for the specific platform that it's running on. Because not all the platforms are going to have the same method name that needs to be called. But the abstraction layer handles that implementation detail. But me as the programmer, me as the person who's using the library, I only need to know about the methods of the library. I don't need to know about the methods of the platforms. Okay, anyways, carrying on. Operating systems often offer more than one native audio API, and some APIs, such as Jack, may be available on multiple target operating systems. PortAudio supports all the major native audio APIs on each supported platform. The diagram below illustrates the relationship between your application, PortAudio, and the supported native audio APIs. Okay, your application, there's the API, PortAudio Common Framework, okay. Then there's implementations for each of the separate native audio APIs. And then there's the OSs themselves. Okay. PortAudio provides a uniform interface to native audio APIs. However, it doesn't always provide totally uniform functionality. That makes sense because like different platforms might have different limitations, or they might have different ways of working, which would make it a little complicated. There are cases where PortAudio is limited by the capabilities of the underlying native audio API. For example, PortAudio doesn't provide sample rate conversion if you request a sample rate that is not supported by the native audio API. Another example is the ASIO SDK. Is that the ASIO SDK only allows one device to be open at a time. So PortAudio/ASIO doesn't currently support opening multiple ASIO devices simultaneously. Okay. Key abstractions: host APIs, devices, and streams. The PortAudio processing model includes three main abstractions: host APIs, audio devices, and audio streams. Host APIs represent platform-specific native audio APIs. Platform-specific native. Okay, alright. I was just trying to say that again in my head to properly understand. Okay, host APIs represent platform-specific native audio APIs. Some examples of host APIs are Core Audio on Mac OS, WMME and Direct Sound on Windows, and OSS and ALSA on Linux. Okay. The diagram in the previous section. Dude, you know what I should try to do? I should try to interface with WMME and Direct Sound and with ALSA on Windows and Linux. Well, no. Let me be more clear about what I was saying. I should try to use these APIs from Rust. The thing is, I'm guessing trying to do stuff with ALSA will require writing C, unless somebody has made Rust. But you know what? Let's look it up. Rust ALSA. Thin but safe wrappers for ALSA. Okay, is there a GitHub for this thing? Rust raw FFI bindings for ALSA. Okay, let's look for. I mean, okay, so there's for ALSA. It's not a very popular one, which, I mean, to be fair, what I'm doing is like it's pretty specific, and I mean, I have very little reason for wanting to do it. It's mainly because I want to do it. If anyone wants to do audio stuff, then they can just use something like PyAudio, right? ALSA linking when cross-compiling Rust programs for ARM. So-and-so. Okay. Okay. Let's look up. Actually, wait, it should already be there, right? Direct Sound, I believe that's part of the Win32 API, isn't it? Yes, it is part of the Win32 API. So, wait a second, what is this? Windows docs Rust? Oh, it just leads to the Windows crate documentation. Though, good to know though. But I think I've seen it before. Anyways, point being, oh dude, I like that they also mention the required features. So like I'll know exactly what I'm supposed to be importing, what I'm supposed to be adding to the crate. But yeah, okay, point being, I can mess around with this if I just start using the Windows crate. So I can mess around with sound stuff in Rust directly. Like if I want to do it with native APIs, then I can do it from Rust directly. What if I want to use WMME? Okay. Wait, there's Rust Port. I think I looked it up, right? Rust Port Audio. Somebody made Port Audio bindings and wrappers for Rust. Oh shit, dude! I didn't think about looking at Python. I didn't think about looking at Rust bindings for PortAudio. Is this still in development? Oh wow, no, it's not. This was in development. Okay, well, I mean, shout out to shout out to the people that contributed to the repo. Um, okay. Anyways, let's carry on with this. I just got distracted. Okay. The diagram in the previous section shows many of the supported native APIs. Sometimes it's useful to know which host APIs you're dealing with, but it's easy to use. Oh, dude, I'm curious. PortAudio, find host API. Or list host API. Yeah, there it is. Enumerating and querying PortAudio devices. So let's see which specific function I'm looking for. Num devices. Oh wait, no, I've done this already. Oh, that's what host API meant. Okay. Real quick, hold up. So, let's go back here. Okay. Right. So before I started learning, have I not transitioned? No, I did not. Okay. Now we're good. So before I started learning about, before I started going deeper into, or when I started learning, let's just say when I started learning about PyAudio, I was trying to do simple things like listing the all the devices and trying to get details about those devices. And at that time, I had seen, hold on, PyAudio. At that time, I had seen these things. So we have, where was that from? Oh, do I need to initialize it? Okay, and then let's also terminate, just, in case. Yeah, there it is. So we have get device count, and I was seeing get host API count as well. And I wasn't sure what exactly that meant, but now it's making sense. Host API. So it's going to list the native audio API. Okay, so let's do that. Wait, this is count, right? And then it's going to be the index. So then I can do p.getHost API info by index. And then I can print this. Oh, there's an error. Did I miss something here? Get host API count. Okay. Invalid host API info. Is there any other error? Hold on, let's do something simpler. Oh, excuse me. All right, let's try getting the default host API info. Okay. All right. MME. Okay, so that's what it's using. And there's 7 devices. Default output device is 4 and input devices. So let's list all the devices. For I in range 0 to p.getDeviceCount. Print p dot get device, I think. Get device info by index I. All right, so we have a couple of things here. Okay, so we are looking for, what was it, number 4, which is the speakers. That is our input. No, that can't be input. P.getDefault host API info. Okay, device count 7. Oh, device count was 7. Dude, I need to introduce like a word wrap kind of thing. Oh my god. This goes a lot further. Default input device is 1 and output device is 4. Oh yeah, the output device is 4. Yeah, that's right. That's right. That's correct. The output device is not coming out of my my audio interface. It's coming directly out of the laptop's sound card. And 1 is correct because it's a microphone for my audio interface. Okay, cool. Nice. All right, so I forgot why I was doing this. Let's get back to reading. Let's get back to reading. Okay. Let's also transition. Real quick. Give me a second. Okay. So, where were we? Sometimes it's useful to know which host. Oh, that's how we got into it. Looking for the host API. Okay. Sometimes it's useful to know which host APIs you're dealing with, but it's easy to use PortAudio without ever interacting directly with the host API abstraction. Devices represent individual hardware audio interfaces or audio ports on the host platform. Devices have names and certain capabilities such as supported sample rates. And oh, I should look for that. Dude, I should look for that. Hold up. Devices have names and certain capabilities such as supported sample rates and the number of supported input and output channels. You know, something that this is one of those things that it doesn't always occur to me when I'm using certain language bindings for a certain library. It doesn't occur to me, like, for example, I I don't think it occurred to me until like very recently that, oh hey, PyAudio is it's Python bindings for port audio. So you're probably going to find more detailed information about how things work in PortAudio documentation, since these are Python bindings for PortAudio. So like if you want a more detailed explanation of how various systems are working, maybe look at the documentation for PortAudio instead. Like I've had similar situations with a couple of other things, because with Rust and Python, you do sometimes end up in situations where you're actually quite a bit with Rust, but also with Python, you do end up in situations where you are using language bindings for a specific library. So like it helps to go and look at that library's documentation itself, even if the library is meant to be used with some other language. Even then, because the library that you are using it contains language bindings for that other library, it helps to go and read up on the other library itself. So you'll understand how various systems work. And this is something that doesn't always occur to me. For whatever reason, it doesn't always occur, or it occurs to me very late. But anyways, okay. It occurred to me whenever it did, so I'm happy about that. Devices represent individual. Okay, I'm done reading that. And I was also thinking about, okay, let's try to get the device info. I'm gonna do that real quick without switching scenes. So I'm gonna print. So let's do p.get device info by index, and the index here is 1, I believe. Yeah, 1. Okay, so let's see what info it's giving. Host API 0. Okay. Oh, what's the host API count? Do I get a count for the host API? P dot man. Okay, let's just, you guys can also see it then. Okay. Right. So going back. What was I going to look at? Oh, get host. I don't think is there, oh, there is a host API count. There's 4 host APIs. All right. Get host API info by index. So let's do 0. Let's do 1. Okay. 0 was what? MME. This is direct sound. This is WASAP, let's say. And this is WDMKS. I wonder what that is. I feel like I've seen that somewhere. Is that something kernel related? WDM, is that Windows driver? I forgot what the M is. Let me just look that up. Is this something kernel related? WDMKS. Windows WDM is Windows native, and even an onboard sound chip should support KS well enough. Introduction to WDM audio drivers. Kernel streaming. Okay, kernel streaming services support kernel mode processing of data streams for audio and for other types of continuous media. Okay, so this is something kernel related. Okay, great. Um, Glad I did that. This is fun, dude. Like reading this, I'm glad that I'm getting these ideas, because like this is what happens. This is how I learn. Like as I'm reading it, I'll suddenly be like, oh shit, okay, let me try and enumerate this. Let me try and get this information. Let me try and get that information. And then I'm like, oh shit, dude, this is super useful. And it's also a good practice for me. It helps me explore the API much more. Where was I with this? Okay. So I'm gonna do this, and then transition. Back to reading. Um, okay, devices have names and certain capabilities, such as supported sample rates. I did not look at the sample rate, did I? That's what I was, well, that's not all I was trying to do, but like, okay, so I'm using, what is it using by default? Get default host API info. It's using 0. It's using MME. Okay. Get host API info by index. What is type? Why does it mention type? Okay, so it's not mentioning the sample rate, the supported sample rate. Oh, maybe it doesn't give that information. Or wait, no, it does. It does. It's devices. I'm looking at, oh shit. I'm supposed to be looking at devices. So get device info by index. I believe I was looking for 1. Okay, so there's the name. There's a host API. Max input channels 2, max output channels 0, because it's an input device. Okay, because yeah, all right, that makes sense. Um, okay, low input latency, output latency. Okay, okay. Default sample rate is 44,100 and no, 44,100. So 44.1K. But it mentions that that's the default. So it's not mentioning the max or the min, which is interesting. Okay, back to this. PortAudio provides functions to enumerate available devices and to query for device capabilities. Streams manage active input and output from and to devices. Okay, so this is where I'm going to have to like start to connect the dots. So streams manage active audio input and output from and to devices. Streams may be half duplex, which is input or output, or full duplex, simultaneous input and output. Streams operate at a specific sample rate with particular sample formats. No, with particular sample formats, buffer sizes, and internal buffering latencies. You specify these parameters when you open the stream. Audio data is communicated between a stream and your application via a user-provided asynchronous callback function or by invoking synchronous read and write functions. Okay, so either we use the callback way or we use blocking methods. Okay. PortAudio supports audio input and output in a variety of sample formats. 8, 16, 24. Oh, they're talking about bit depth. Format. Yeah. Wait, format? Would that be the bit depth? Yeah, that's the bit depth, isn't it? That's the bit depth. They're just not calling it the bit depth. Okay, so it supports 8, 16, 24, and 32-bit integer formats and 32-bit floating point, irrespective of the formats supported by the native audio API. PortAudio also supports multi-channel buffers in both interleaved and non-interleaved, separate buffer per channel formats, and automatically performs conversion when necessary. If requested, PortAudio can clamp out of range samples and or dither to a native format. Okay, PortAudio API offers the following functionality: initialize and terminate the library, enumerate available host APIs, enumerate available devices either globally or within each host API, discover default and recommended devices and device settings, discover device capabilities such as supported audio data formats and sample rates, create and control audio streams to acquire audio from and output audio to devices, provide stream timing, information to support synchronizing audio with other parts of your application, retrieve version and error information. These functions are described in more detail below. Okay, the PortAudio library must be initialized before it can be used and terminated to clean up afterwards. You initialize it by calling so-and-so and clean up by so-and-so. You can query PortAudio for version information to get a numeric. Okay. The size in bytes of various sample formats represented by PA sample format, by the PA sample format enumeration, can be obtained using get sample size. Okay, yeah. PA sleeps for a specified number of milliseconds. This isn't intended for use in production systems. It's provided only as a simple portable way to implement tests and examples where the main thread sleeps while audio is acquired or played by an asynchronous callback function. Okay, sorry, I zoned out for a little bit there. Okay, host APIs. A host API acts as a top level grouping for all the devices offered by a single native platform audio API. Each host API has a unique identifier, a name, zero or more devices, and nominated default input and output devices. Host APIs are usually referenced by index, an integer of type so and so that ranges between whatever. Okay, yeah. You can enumerate all available host APIs by counting across this range. You can retrieve the index of the default host API. Information about a host API, such as its name and default devices, is stored in host API in a host API info structure. Oh, okay. In the Python, in the case of Python, that would be a dictionary. It returns a dictionary. You can retrieve a pointer to a particular host API. Okay, that's, yeah, fine. Great. Most PortAudio functions reference host APIs by uh, host API indices. Each host API also has a unique type identifier defined by so and so. Yeah, what is a type thing? You can call host API type ID to host API index to retrieve so and so. What is What does type mean here? Unchanging unique identifiers for each supported host API. This type is used in the host API info structure. The values are generated to be unique and to never change, thus allowing code to be written that conditionally uses host API specific extensions. New type IDs will be allocated. What is the difference between, hold up, PortAudio, um, host API index versus type ID? Okay, maybe I'll Google this later. Yeah, maybe I'll Google this later. It's fine. It's not that important right now. Okay, devices. A device represents an audio endpoint provided by a particular native API. This usually corresponds to a specific input or output port on a hardware audio interface. Wait, no, let's run that back. A device represents an audio endpoint provided by a particular native audio. Man, it's becoming hard to talk. Give me a second. Let me hydrate. Okay, where was I? Um, okay. A device represents an audio endpoint provided by a particular native audio API. Okay. This usually corresponds to a specific input or output port on a hardware audio interface or to the interface as a whole. Each host API operates independently, so a single physical audio port may be addressable via different devices exposed by different host APIs. Each host API operates independently. Okay. A device has a name. It's associated. No, a device has a name, is associated with a host API, and has a maximum number of supported input and output channels. PortAudio provides recommended default latency values and a default sample rate for each device. To obtain more detailed information about it, about device device capabilities, you can call the is format supported. No, you can call is format supported to query whether it is possible to open a stream using particular devices, parameters, and sample rate. Okay, let me give that a try. Okay, it has is format supported. Rate, input device, input channels. Checks if a specified device configuration is supported. What is my device? 1. The device is 1. So let's go for 41,000. I don't remember. I don't remember all the all the sample rates, but okay. Device 1, input channel 1, format. Oh, it's checking if format is supported. Well, what about sample rate? How do I check if sample rate is supported? P dot is sample supported? No, that doesn't work. All right. Input format. So that would be P dot or well PyAudio dot PA 16 int 16. I don't think I need to give all of the. Okay, so it's supported. What if I do 81,000? What if I do 121,000? What if I do 301,000? It's still saying yes for everything. I don't think it's checking the sample rate. I think it's just checking the format. So the bit depth. I think that's all it's checking. Maybe I have to mess around with it more. Okay. Although each device conceptually belongs to a specific host API, most port audio functions and data structures refer to a device using a global host API independent index of type device index, an integer of the range so and so, so and so. Okay. The reasons for this are partly historical, but it also makes it easy for applications to ignore the host API abstraction and just work with devices and streams. Okay, if you want to enumerate devices belonging to a particular so-and-so, I think we've done all of this. Okay, that's fine. Information about a device is stored in so-and-so structure. Okay, you can retrieve a pointer. Great, great, great. You can get defaults. Okay, awesome. Okay, great, cool, nice. Wait, just real quick, let's take a look at the C code. Where's the code? Oh shit, is the music still going? I think it stopped like a while back. Holy shit, I completely forgot about the music. Okay. Uh okay, yeah, I didn't really have anything specific in mind. I just wanted to look at some C code. Yeah, I wanted to see what the C code here was. Okay. Streams. Okay, this is where it gets interesting. This is what we came here for. A stream represents an active flow of audio data between your application and one or more audio devices. A stream operates at a specific sample rate with specific sample formats and buffer sizes. I/O methods, callback and read-write. PortAudio offers two methods for communicating audio data between an open stream and your application. The first is an asynchronous callback interface where PortAudio calls a user-defined callback function when new audio data is available or required. Oh, when it's available. Okay. And the second is synchronous read and write functions, which can be used in a blocking or non-blocking manner. Wait, how do you use it in a non-blocking manner? I need to look into that. Or like at least, I mean, more specifically on the PyAudio side, the Python side basically, how I can use the non-blocking thing in PyAudio. You can choose between the two methods when you open a stream. The two methods are discussed in more detail below. Okay. Opening and closing streams. You call OpenStream to open a stream, specifying the devices to use, the number of input and output channels, sample formats, suggested latency values, and flags that control dithering, clipping, and overflow handling. You specify many of these parameters in two. Okay, that's fine. That's C specific. One for input, one for output. Okay. If you're using the callback IO method, you must also pass a callback buffer size, a callback function pointer, and user data pointer. Okay. All right, that's C specific. Devices may be full duplex, supporting simultaneous input and output, or half duplex, supporting input or output. Usually this reflects the structure of the underlying native audio API. When opening a stream, you specify one full duplex device for both input and output, or two different devices for input and output. Some host APIs only support full duplex operating with a full duplex device, but most are able to aggregate two half duplex devices into a full duplex stream. PortAudio requires that all devices specified in a call to OpenStream belong to the same host API. Okay. Okay, so I'm trying to think of what are the different ways that I'm going to be using the audio. So one of them is definitely for the closed captioning system, right? So I'm going to be capturing chunks of audio and sending those chunks into the ML model. Just a second. Dude, actually, I might need to come up with like a queuing kind of system. I might need to make a queuing kind of system. Unless I want to start offloading things to different threads, which, I mean, I'm already going to be doing that, considering they're running on different Python scripts. I'm already going to be doing it on a different thread, but I want to try and use as this processor might have 6 cores, I think, or 4 cores. Where is the information? Well, not this, I'm saying this, but I mean the other system that I'm running on. I don't remember. Give me a second. So we have application, we have history, CPU usage. 4. Okay. So it has 4 cores. Alright, that works. So I'll then be able to offload, at least 4 different applications, which is great. But like, I want to further try and like I'm wondering if using multi-threading in some way could help here, but I feel like it would just unnecessarily complicate things. Besides, I don't know how thread safe some of the other models are going to be, so that's another issue. Yeah, I need to take that into account as well. I don't know how thread safe they're going to be. Yeah, I think I'll just be happy with, it running on one or on a separate thread, because the Python script itself is going to be running on a separate thread. I'll just be happy with that. That's fine. But yeah, I'm going to need to come up with some kind of queuing system that waits for the results to come back from the model, unless I want to have like multiple instances of the model which would be running. But that seems unnecessary, especially because I don't want one message coming before. Well, I mean, I don't want. I want the messages coming back in order. I don't want them coming in like mixed order, because that's not going to make sense, especially since closed captioning. So it has to be in the order in which I'm saying. So in the order in which I'm speaking, like the text that's coming has to be in the order in which I'm speaking. So, okay, that's going to be one use case, right? That's one definite use case. Another use case that I have is the fact that I'm saying something means like I'm talking, right? It's capturing some kind of audio. So I want to send signals of that into the VTuber app, so that I can then apply that to my avatar, and it'll show like each time as I'm talking, there's going to be something moving in the avatar. Maybe something expands, or maybe something lights up, or something like that. So it basically says that I'm talking, or it signifies that I'm talking. So I can do some interesting effects with that. I can design, and I need to design an audio protocol as well. I'm gonna have to see how to go about doing that. Yeah, I'll have to see how to go about doing that. Because the thing is, I'm not gonna be sending audio into the VTuber app, at least over the network. I'm not going to be sending audio in. But each time like some kind of audio thing happens, some other data is going to be sent into the VTuber app. So technically, I don't need an audio based protocol. I can just use a regular, like the DVT-MP message packed protocol. Yeah, I can do that. Man, it is becoming hard to speak. Like, holy shit. It's gonna be rough for the next couple of hours for me. But hey, it is what it is. Where was I here? Okay, so we read about the duplex thing. A successful call to open stream creates a pointer to a PA stream. Okay, alright, so the Python version of that is it returns like a stream object or something. What is it return? Let me just look at that real quick. Stream is, what is this? Yeah, it just returns a stream. Okay. So it returns a stream object. Okay, PortAudio also provides Open Default Stream, a simpler alternative to OpenStream, which you can use when you want to open the default audio devices with default latency parameters. You can call close stream to close the stream when you've finished using it. Starting and stopping streams. Newly opened streams. Hold on, how much more of this is remaining? I don't think I'll be reading the callback thing. I cannot talk much longer. So I think I'll be reading this later. Okay. You call, is that where I was? You call open stream. Wasn't there a default thing? I think I was almost done with this, wasn't I? Oh, starting and stopping streams. That's what I was reading. Newly opened streams are initially stopped. You call start stream to start a stream. You can stop a running stream using stop stream or abort stream. The stop function plays out all internally queued audio data, while abort tries to stop as quickly as possible. Okay. An open stream can be started and stopped multiple times. I don't think I've been starting it. On the Python end, I don't think we are required to start it. It just goes, you just directly jump into reading. Okay, cool. Where was I? An open stream can be started and stopped multiple times. That's actually good to know. It can be started and stopped multiple times. You can call is stream stopped to query whether a stream is running or stopped. By calling set stream finished callback, it is possible to register a special PA stream finished callback that is called when the stream has completed playing any internally queued buffers. This can be used in conjunction with the PA complete stream callback return value to avoid blocking on a call to stop. I'm just losing track of this sentence. This can be used in conjunction with the PA complete stream callback return value to avoid blocking on a call to PA stop stream while queued audio data is still playing. Okay. Just a second. Hold on, excuse the silence. Give me just give me a second. Okay. So, I guess we can keep reading. I have not looked into the callback side, but I kind of get the idea with the callback as well. Okay, the read-write IO method. As an alternative to the callback method, PortAudio provides a synchronous read-write interface for acquiring and playing audio. This can be useful for applications that don't require the lowest possible latency or don't warrant the increased complexity of synchronizing with an asynchronous callback function. اندمج فيما يعجبك مع يوتيوب بريميوم. شاهد الفيديوهات بدون إعلانات وبالإنترنت ومع إمكانية تشغيلها في الخلفية. جرب يوتيوب بريميوم. Where was I? This IO method is also Okay. Shit, where was I? This IO method is useful when calling PortAudio from programming languages that don't support asynchronous callbacks. Okay, to open a stream in read/write mode, you pass, okay, this is C specific. To write audio data to a stream, you call write stream. And to read data, you call read stream. These functions will block. Hold on. So reading the stream. Now this is what I was trying to understand, right? Reading the stream and writing the stream does read samples from an input stream. This function doesn't return until the entire buffer has been filled. All right. This may involve waiting for the operating system to supply the data. Reading from a stream that is stopped is currently not so okay. That's okay. So I think what I have here is stream.read. It's the number of frames. That's the okay. So I don't need to look at buffer. I need, what does this return? Oh, it returns an error. That's why buffer is separate, because it's probably internally writing to the buffer. So here we have frames. The number of frames to be read into the buffer. This parameter is not constrained to a specific range. However, high-performance applications will want to match this parameter to the frames per buffer parameter used when opening the stream. Okay, so what I'm getting here, what I've understood so far is that just a second. Okay, where was, oh yeah. So what I've understood so far is you create the stream, right? And then you read from that stream. It's gonna read how many samples you tell it to read, or how many frames you tell it to read. And then it's gonna return. It's gonna return back after reading those many frames or those many samples. So what I'm thinking is, like, what happens if we set the frames too high, or well, higher than 1024? I need to experiment and see what would be the difference between reading one frame and reading, let's say, 4096 frames at a time. Because, dude, like with a sample rate of 44,100, like what if I decide to read 44,100 frames? There must be a limit to how many frames it can read, but I need to experiment more and find out what the potential drawbacks can be, because there has to be a reason why it was using where is it? There has to be a reason why it was using this there's got to be some reason. They must have seen some sort of benefit in that. But yeah, I need to experiment more with this and see what the reason is. But I'm glad it's kind of starting to make more sense to me now. That, oh yeah, okay. So it's gonna block until it's read that many frames, and then it'll return those frames. So you want to read it in chunks, right? But the frame rate is 44,100. And the number of seconds is how many ever seconds we are setting. So we kind of have to factor those into the equation as well, right? We could read 44,100 frames. I mean, we could try to read. I don't know if we will be able to read. I'm gonna have to experiment and see if there's like a maximum. Because if it's blocking anyways, then, like, you know, what's stopping me from having a bigger size of frames to read? I need to see if there's going to be some performance drops in that, or what if there's performance gains in that? Give me a second. Right, okay. Cool. So, that's gonna be it for today's stream. Do stick around. I'm gonna be rating a person. They go by Dezubi. And yeah. So let's set up the raid. Okay, cool. So that's gonna be it for today's stream. I hope you guys enjoyed, and I hope, I mean, I enjoyed. That's for sure. I always enjoy doing these study streams. I will try to stream again. Dude, I definitely don't want to miss more streaming days. So I'm going to try and stream again as soon as possible. But I'm definitely going to be doing more of this audio stuff. Hopefully more of it on stream. But yeah, that's going to be it for today. I hope you guys have a nice day, and I will see you all next time. Peace.